Hello YouTube, we're going to be talking a little bit more about regression analysis. In a previous video I talked about linear regression, and this was the formation, the formula for it, which was y equals beta naught plus beta 1x. And that was for, you can kind of compare it as y equals f of x. So it's a function with one variable, an independent variable and a dependent variable. And you're only comparing two things pretty much, as one thing changes, what happens to the other. You can compare this. I used this weight and height example in the previous video as well. If you notice, this is also similar to the y equals mx plus b equation, b naught being your y-intercept, b1 being your slope. And we were comparing weight to height and seeing if there was a relationship. So now what if you had multiple variables? So you have your y-intercept, and then you also have your accounting for weight. But what if you account for other factors too? Because not only does one thing affect another, sometimes multiple things affect one thing. So this is a multivariable outline for for a regression analysis. So for example, if you wanted to take height into account, gender into account, muscle into account, because muscle weighs more than fat, gender, there is difference being a male or female, in terms of sex, which how your weight will be. If you're, guy, you probably weigh more. So, and if you're a girl, you probably weigh less. So, now, here, what we can do is we can insert a dummy variable, and by doing that, we can say, okay, 1 will represent that the individual is a female, and 0 will represent if the individual is a male. This is kind of like a yes or no thing. You can also do if you were comparing something, saying, oh, this is true, this is false, 1 being true, 0 being false, something like that. You can also do in terms of a dummy variable, depending on the context. Now, this is a binary kind of thing, so it's either one or the other. So since our beta 1 represents our slope, it's pretty much saying, like, how much weight are we adding per inch? And that is controlling for gender. This is kind of the thing where we would be able to take an analysis into account by controlling for gender, how much weight we'll be able to add per inch. So another example here, if you want to take a look, if you wanted to control weight, you can say, okay, you have the y-intercept plus the coefficient of the, say, height, plus the slope of the height for female, and the same thing with male. You would do that as well. And you would get a graph that looks something like this. And notice this difference. When you control for a variable, the slope remains the same. However, the y-intercept in itself changes. So slope does not change, the intercept does. Okay, so now we're going to go on to a few more things, just kind of like doing an overview of concepts. So functional forms. So this is a polynomial, a linear form, and y equals mx plus b kind of thing. And then we have a second one. If we had a polynomial in which x is squared, you would have a polynomial relationship, like maybe a parabola, using stuff like that. And you can take the derivative of those and get relationships as well using calculus. But you can also use logarithms to display another way of a functional form. And there's 3 different types we'll look at: a double log and semilogs. And what this pretty much represents, if you notice, log kind of means is kind of like saying percent change in one variable, and pretty much what the saying is, like, if you increase height, if you increase by a percentage in height, for example, what will be the weight percent change, is kind of like what this is asking. Now the second one would be, like, if you increase height, would be height or weight? It would be, if you increase weight, what is the percent change in height? Or actually it'd be reversed. So if you increase height, what would be the percent change in weight? And then this last one, if you increase weight, what would be the percent change in height? Pretty much the percent changes depending, I forget which variable was x and y in the previous. But what the logarithm shows is that percent change. So if you notice how the ln of y and the ln of x in the double log shows the percentage both, wherever the ln is, or the natural log, that's kind of going to be where the percent change is located. And one thing I kind of want to end on here, in terms of when you talk about doing a regression analysis, it's not really a regression analysis, it's a regression analyses. plural. Like, you have to do a bunch of regressions. It's not just one regression is going to give you the answer. You got to keep analyzing your data, whether it's in science, even in economics or wherever it is. Definitely have to do multiple tests. And this was kind of looking at multivariable sort of things, and I just thought I would preview it and hope it was something worth enjoying, I guess. So, best of luck to you all.